Okay, so we are going to talk about absolute errors and relative errors. So there's two examples. So the first one is calculate the absolute errors and relative errors when we try to approximate pi, and using three values, a equal 3, b equal 22/7, and c is 355/113. So the absolute errors is the absolute value of the approximation. In our case is a minus the exact value. So in our case is pi. So when you have a equal 3, then we just have 3 minus pi. Okay, and if you put into your calculator, then you can have the results. So this one, it will be 14159. So up to 5 digits after the dot. Okay, and then the relative errors. So the relative errors of A will be the absolute errors divided by the absolute value of pi. So in our case, because pi is positive, so absolute value of pi is still the same as pi. So like 0.14159 divided by pi. And then you get 0.04507. Okay. And similarly, now if I have a better approximation, so I use b to approximate pi. So I have absolute errors of b will be absolute value of b minus pi. So I plug in b is 22/7, then minus pi. Then I will have 0.0013. Okay, and then the relative errors. So relative errors will be absolute errors divided by the exact value. So in our case, this one will be 0.0013 divided by pi. And you plug in the calculator, and you will have the results will be around 4.025 times 10 to the minus 4. Okay, and the last one is you just take the value of c, right, minus pi, take the absolute value to derive the absolute errors of c. And this one will be 355 divided by 113 and minus pi. And then this one gives you 0.67 10 to the minus 7. Okay, and similarly, you can have the relative errors of c. Okay, so it will be absolute errors of c divided by pi. And so absolute values of c minus pi, absolute value divided by pi. Okay, and it will be around 8.49 10 to the minus 8. Okay, so now, there's another type of question. So suppose now you want to store x equals 0.12 or y is 1.2 billion into the floating point system, inside MATLAB. Then what is the rounding errors? So in this case, the rounding errors will be the absolute errors Okay, and because the absolute errors will be the relative errors times the value of the of x, okay, and because you store inside the floating point system, so suppose you store inside MATLAB, then the relative errors will be epsilon. So remember, epsilon is the one we discussed before, so it's the gap between one and the next machine number. Okay, so in this case, we can approximate epsilon is around 2.2 10 to the minus 16, sorry, 2.2 times 10 to the minus 16, and time absolute value of x is just 0.12. Okay, so when you plug it in this number in the calculator, then you will get 2.6645 10 to the minus 17. Okay, so very, very small number. However, so this is a rounded errors of x. Okay. However, when you try to store a very big number like y, then the rounding errors, so the rounding errors when storing y, using the same formula, will be epsilon multiplied by absolute value of y. So will be 2.2 10 to the minus 16. But see, now y is a billion, so 1.2 billion. So it will be 2.64 10 to the minus 7. So you see, when you store a very big number in the floating point number system, then the rounding errors is bigger. So you see, for a small number, the rounding errors is around the machine epsilon. But when you store a billion, then the rounding errors is like 10 to the minus 7. So be very careful when you store big numbers in MATLAB. So that is everything about absolute errors, relative errors, and rounding errors.